Welcome back. In this lecture, we will look at some commonly used programming constructs in Java. And again, some of these programming constructs are available in other programming languages, although the terminology may be different. So at the end of this lecture, you will be able to implement simple Java programs using the commonly used program constructs. So the construct that we are covering here is the concept of packages, static import, using the super and final keyword, and the concept of inner classes. So packages is a namespace where we use to logically group related classes. So you might have already seen this. So you might have imported the classes, because without importing, for example, you can't use classes like array. So you must import. So this means you have to, the related classes are grouped into classes and interface, of course, into a namespace which we call the package. So think of the word package. So it's like putting certain things and trapping it. So that's exactly what is happening here. We are putting set of classes and interfaces that are related into a namespace and call it a package. So it is a good way to organize your code, and also it provides access protection, which we will later see. So here's an example. So we are implementing a solution to a bicycle shop. So we need to have bicycle class and football cycle class and kids cycle class, but all these are belonging to the same solution. So we can pack them into a package called bicycle shop. So if you are programming with an IDE like Eclipse, you don't have to create a package always. If you don't create a package, then it will use the default package. But if you have a lot of classes, you see some kind of logical grouping, then please use this package concept to group your related classes and interfaces. So as I told you, with this packaging concept, we get different level of accessibility. So you have seen these words before, at least the word public, private, and protected. These keywords are applied to methods and attributes in classes. So depending on the keyword, which we call accessibility modifiers, how these methods and attributes can be accessed differs. For example, if there is the access modifier public, it whether it's a method or an attribute, it can be accessed only within the class itself. But we'll start with the public one. Sorry, I made a mistake, I think. So if the modifier, access modifier is public, whether it is a data attribute, that means attribute, whether it is a method, that those can be accessed within the same class, within the package, within the subclass, and from any other class in your application. So here word means any other class in your same application. The second access modifier, protected. So if an attribute or a method has been marked as protected, they can be used, of course, within the class and with by any other class in the same package, and any subclass in any other package, but not from any other place. And you can also look and define without any access modifier. So examples I have given here below, so I'm referring to the third option here. We just say int C. So which is the case where we have no modifier. So those attributes and method can be accessed within the class, within the package, but not by subclasses or the word. So in other words, if the subclass is within the same package, it can access, but if the subclass is outside the package, it cannot access. Finally, the private access modifier. If a method or an attribute has been marked as private, then it can be accessed only within the same class. not from another class in the same package, not from a subclass, not from any other class. So as you can see, the highest restriction comes from the private keyword, and then by the no modifier option, then the protected option, and finally the global open one, the public option. So as you can see, with the introduction of the package, we have added another level of accessibility. So if you want a class to be accessed only by a set of classes, then you can pack these classes into a package so that we can control the access. So when we pack the classes into different packages, now sometimes a class in one package wants to call a method in a class that is in a different package. So in that case, we have to import these packages into our current class. So there are different ways to import. You can import the whole package, so all the classes will come. And sometimes within the package, we can have sub packages. So there's a packaging structure. So if in such a case, rather than importing the whole package, we can import a sub package, or else we can import only a specific class. Of course, you can still write code without importing specifically, but in that case, every time you refer to a class or an interface, the full qualified name has to be used. The full qualified name is package name dot sub package name dot sub package name dot, likewise finally the class name, which is very cumbersome. But if you use the import keyword, the import statement will be common to the given class, and you can simply use all the constructs within that without having to use the full qualified name. The next concept is of course related, the static import. So similar to the previous case, if you want to import the static classes like the math and all, you can use the static import. And the other concept is the super keyword. I hope you remember we discussed this keyword, right? So this keyword refers to the current object. So similarly, the super keyword refers to the constructor of the superclass. For example, now here we have the subclass monster, which extends the superclass game inhabitant. So within the, as you can see, within the monster constructor, we are having a keyword called super. So what happens here? Within the monster constructor, when we say super, it will go and call the constructor of the superclass. Here the superclass is game inhabitant. So when we say super within the monster constructor, it will go and call the superclass constructor. So if the superclass has multiple constructors, based on the parameters that we pass, the Java runtime environment will automatically resolve the correct superclass that we are referencing. So similarly, if you want to access a method, for example, if you in the monster class, now I want to access the a method of the game inhabitant class. So we can say super.a method. So now you might wonder why I have to use super, because earlier we said we don't have to. So now in this case, as you can see, even the monster class has an a method, but in this case, I specifically want to call the a method of the super class. So in that case, I can use the super keyword, and with that, I will be referencing the a method in the game inhabitant class. But if this super keyword was not there, I will be just referencing the a method in the monster class itself. Similarly, if you want to access specifically access an attribute from the superclass, you can use the super keyword. As you can see, the int name is a protected variable. So as we showed earlier, if it is a variable with the protected modifier, we can access that attribute from the subclass. So that is what we are doing here. When we say super.name, it will go and access the protected int name attribute that has been defined in the game inhabited. So if you did not have the super keyword, then when I say name equals new name, it will refer to the int name defined attribute defined in the monster class. Of course, having the same attribute name in the superclass and subclass makes the superclass attribute to be hidden to the subclass. So if you want to access it directly, you have to use the superclass. However, having an attribute with the same name in the superclass and subclass may not be a good idea, as we discussed earlier. So the next keyword is the final. So this final keyword can be used in multiple places. If you use the final keyword with a variable, then that variable cannot be reassigned. So if I say final int number equals 10, and within that object where the number is 10, you can't change that. That number will be 10 always. And similarly, we can have static final variables also. So it is same as the simple final variables. The only difference is this value is now common across all the objects that are created from this same class, just like other static variables. And if we use the final keyword with the method, for example, here final void characteristics. If we have such a method in the superclass, the functionality can be inherited, but it cannot be overridden. That means a subclass cannot have a method called characteristics because the superclass characteristics method is final. And finally, if the final keyword is used with the class, for example, if we have a class called final class monster, this means this class cannot be inherited, right? So although it cannot be inherited, it can be instantiated. That means we can create objects from the monster class, although we cannot have subclasses for the monster class. So this concept is different from abstract classes. Don't get confused. In the abstract class, we can't make object from an abstract class, but the subclass can extend the abstract class. When in the final class, we can of course create objects from that final class, but we cannot extend that final class. So what if there's a class with abstract and final both keywords? Actually, it is not meaningful, right? You can't extend that class. You can't create object from that class. Then what's the point of having such a class? So normally a class can be just a normal class, or it can be a final class, or it can be an abstract class. So the final concept we are going to discuss is inner classes. Sometimes you have an object that is complex, and you see within that class there are some complex properties. They are specific to this class. Remember cohesion. So these properties are complex, but they serve the responsibility or the total direction of this class. So you cannot move them out. So you have to keep them inside the same class, but when we have all that code inside the same class, the class looks very complex and cluttered. So in that case, what we can do is, within the same class, we can create another class, which we call a nested class. So as you can see here, we have the outer class. Inside that, just like how we are defining a method or something, we are having an inner class. So this inner class can be public or private. So if it is private, it can be used only by the outer class. If it is public, It can be used by any other class, but the access has to be done through the outer class, just like how we access the method in a class. So we can have a static inner class as well, but it can, if in such a case, to access that inner class, we don't have to create an object from the outer class. So just like how we access that static method, we can simply use the static inner class using just the class reference without having to create an object of the outer class. So a similar concept is the anonymous inner class. So to understand what anonymous means, let's go back and look at this inner class. So when we explicitly define inner classes, we have to give a name. So here we have given the name as inner class. So it has a name. In contrast, anonymous classes means classes that are defined without the name. So as you can see here, so I have a monster abstract class and I create an object using this monster abstract class without having a subclass. So if you write a code like this, monster m equals new monster, and within brackets, we provide the implementation that should go into a subclass, right? So this looks a bit confusing. So don't think that we are creating an object of the monster abstract class, which is not possible. What we are doing is we are just using the monster constructor, but we explicitly say when we actually create this object through this constructor, we are actually creating a new object that belongs to an anonymous class. So here, as you can see, no class name. We just go by the reference to the abstract class. It can be an interface as well, but we are creating an object. And after creating that object, you can just use that object through this reference. So here, monster M, this M reference can be used after it has been assigned an object by creating it through this inner class declaration. So this concept of anonymous classes you can find in the standard Java API as well. For example, when you're creating threads in concurrent programming, which we'll be learning later, when we are creating a new thread, we can simply easily create a new thread without having to have a class defined. So a new thread is our topmost class. Without defining a new subclass class name, we are now creating an object just by using this abstract thread class. And within that method, we provide the implementation to the run method, which is abstracting the thread class. So in summary, we learned some other related concepts when we are using Java programming. These are the packages, the super and final keywords, and then the inner classes, which are anonymous and non-anonymous. So in the coming lecture, we will be looking into the concept of UML, which stands for Unified Modeling Language. Thank you.